Hi everyone, and welcome to this third Octave developer session dedicated to what's new in Octave, your monthly rendezvous with Sierra Wireless Edge to Cloud data orchestration IoT platform. As always, this session is presented by a member of Octave development team at Sierra Wireless, and with me today, it's a pleasure to welcome David Bonnet. Hi, David.
Hello, Thibaut. Good morning and good afternoon, everyone.
So David is a senior staff engineer, front-end development in Octave team at Sierra Wireless. David and his team are actually responsible for the development of the nice Octave UI, the user interface we all use each time we use Octave on our computer. So I'm sure you will have plenty of questions for David today. Either on the new features David will present, so more on that in a minute, or about Octave UI in general, or how his team works, etc. So please use the chat at any time for your questions. As usual, we'll take them on the fly when we can, or we'll keep them for the Q&A part at the end. I'm sure you are already familiar with Octave, although if that's not the case yet, I would recommend you to check out Octave tutorial videos on Sierra Wireless YouTube channel. And as usual, this session is recorded and will be added to our YouTube channel in the coming days. So before we start today, I'd like to say a word on the feedback you gave us so far through the ending survey of these live sessions. And thank you for that. That's really helpful for us to drive these sessions. And it seems that many of you would like to see more real use cases with real implementation using Octave features. So I have the pleasure to say that next time, on March 11th, we'll include such real use case implementation. And we'll ask you, one of you from Octave developer community, to join me virtually on this stage and show how you use Octave, any particular Octave feature you are using actually for real use cases. So if you're interested in joining me in any of these next sessions and share how you use Octave for your IoT application, please send me a message. You'll find my email address at the end of the session. Now, let's see the agenda for today. And David is coming with a nice brand new feature, Octave Tasks, and more actually. David?
Yes.
The mic is yours.
All right. Thank you, Thibaut. So again, good morning or good afternoon, everyone, and the ones that joined during Thibaut's initial presentation. So let's start. And I hope, yeah, it works. So I do a brief recap of what Octave is, and in order to introduce the new feature. Octave is mainly an event-based IoT solution. So on the left, you have the industrial assets, sensors, for instance, that produce data. And whenever a new data appears, that's an event. We have data-based event that then get processed by our devices and pushed onto the cloud. And there again, we have the same metaphor where we have events with data that get processed by cloud logic and then sent to cloud services. And this goes both ways. Of course, you have stuff that happens on the cloud that then gets pushed back onto devices. So it's an event-based solution, and on the device we have resources which generate data, and they produce them in events. These are then observed in observations, they're captured and then routed to either actions for some transformations, or sent to the cloud. And on the cloud, again, we have streams that capture these events and then send them to actions eventually to transform them, and then also to connectors in order to send them to cloud services. But that's mainly about data that is produced and that happens because a sensor triggered it, or because we called some API on the cloud. But what about events that are not produced by new data, but by time? So on the edge, we have a solution, which is timers that were introduced in the first session of the What's New. But what about the cloud? And that's where tasks come in. So cloud tasks, are the equivalent, I'd say, to timers on the edge. They enable to use time in order to produce new events. So what are tasks? Tasks are periodically executed JavaScript functions. And in these functions, you can return events to inject into streams. So you can produce new events and then convert a time-based event into a data event. And so basically, they work like cloud actions, but they have a slightly extended device API. Namely, in there, you can update devices. So what can you do with tasks? And more broadly, what can you do with time-based events? Well, quite a lot of things, actually. One thing is about monitoring the online and offline status of devices. Because, well, usually in the IoT world, I mean, devices have an asynchronous behavior. Sometimes you never know when a device is going to execute or when it's going to do something, because, well, mainly most of the time it's based on something that happens that triggers a sensor that then will produce an event, and then it cascades up to the cloud and gets processed there. But you never really know if that device is actually, I mean, if you don't have any information about the device, it doesn't necessarily mean that it's good news. So there's this saying where no news is good news, but in the IoT world, it's, you don't know. So what I want to show you is how you can leverage tasks to describe with your predicates what you would consider a device to be offline. So let's jump right to it. So in the app here on the sidebar, you have a new tasks navigation item that is here. And so you can add a task, you can filter them as for any other cloud entity, like actions or streams or connectors. And so here we have a bunch of tasks, and we're going to look at this one. So this is a task. At the top, you don't specify, like for cloud action, a stream as an input, but you specify the periodicity. Like how often should this task be executed? And so yeah, so here, I mean, here it's supposed to run every 2 minutes, but it's disabled. That's why the next run is meaningless. So then, what about this task? So here we are specifying a filter with an offline threshold of 5 minutes. So if you notice, I like to start my tasks with some variables that express the different time units. So like minute, hour, day, makes it easier to read afterwards. So here we have this offline threshold, which is the current timestamp minus 5 minutes. And so this means that a device that hasn't communicated in the last 5 minutes is considered as offline. And then, since we don't want to have too many devices reported as offline, because probably the other ones are already offline, so we don't necessarily need to know about them, we added this second condition here, where we say, okay, devices that have been reported as offline more than 1 day ago, we don't want to see them reported here. And so here we perform our query, and so we look for devices that match this filter that we express here, and we extract their IDs, and then we store that in a stream that is called share wireless offline, and we store the IDs there. So how does it look like when you run it? So we ask for Cloud Actions. We have a simulator, and here we don't have to specify an event as an input. We can just run it. And so yeah, here it looks good. There are no devices offline. So let's increase the second threshold a little bit. That's still nothing. Probably have to add like 5 days, because I know that we have some devices that didn't communicate. Okay, and so in case you haven't played with the simulator, it's quite nice. You can hover over the icon and it will highlight the piece of code that is responsible for that simulation result. And if you click, it selects that code, and so you can very easily edit it. So here we see that it found one device that matched our predicate. The other thing that you can do with tasks is to pull data from systems that do not offer subscriptions. And by that, we mean that, I mean, there are some APIs that you have to call periodically in order to extract some data from it. I mean, it's common that you have a service that offers an API, but it doesn't offer any subscription methods, any way to provide a callback that will call your API when something happens. And in that case, you need to poll regularly the API in order to see if it has changed. So this is the case for RSS feeds, but in this scenario, it's about a weather forecast API. So I play the role of a yoga instructor, so you can close your eyes and imagine that you are on an island. Actually, here it's in the Mediterranean Sea. We are on an Italian island, and as with most tiny islands, they've been created because there's a volcano. And I mean, the scenery is quite nice, but it can also be quite dangerous because volcanoes can, of course, wake up and destroy everything around them. So the idea is to monitor these volcanoes. And for that, there's nothing better than to use CR wireless solution and to put devices with seismic sensors and temperature, and why not even sensors that measure the moisture of the air in order to be able to alert someone about an unusual activity that could lead to an eruption, for instance. So we have all these devices. They measure seismic activity, air composition, and well, they're in a location where you don't have electricity nor an Ethernet cable where you can transfer all your data. So that's why you need to use cellular and battery-powered devices. So the purpose of these devices is to send messages to alert about unusual activity. So they have to be able to work constantly and to alert at the right moment when something's up. And in addition to that, they should also send periodically large recordings about the seismic activity. And the problem is that for battery-powered devices, sending lots of data is very energy intensive. So the idea is, in order for them to send periodically large recordings, the idea is to do that only when the following days are sunny and when there's enough sunlight to shine on their solar panel in order to recharge the battery. And for that, we need a weather forecast. And where are we going to get that weather forecast? Well, by using a task to pull the forecast information and then to determine whether or not we should ask these devices to send their data, because then we will know, okay, if they do it at this time, in the next 3 days, they will be able to have enough sunlight. Let me show that in a demo. Okay, so this task here is slightly more complex, but we're still under 50 lines of code. So again, we have here my usual time units at the top. And so how does this task work? Well, first, we want to ask the devices to send these recordings only once every 3 days, for instance. And for that, this task needs to know when it asked about that the last time. So to remind the task about when it did that, we use this stream here to store when the last query happened. So we use the octave.event.find1, so it returns the latest event by default. And then if there was an event return, it could be that there's no event in the case it ran for the first time. And then if the creation date is less than 3 days, then we do nothing. And that task should run like every hour, for instance. And then the second thing is, this is something you could do as well, is to store some special API keys in OneStream that not everyone has access to. So you can use the groups and permissions to prevent access to that stream, and only you or a couple of company members can see it. And so here we're using that to store the open weather API key in order to query its API and then fetch our weather forecast. So here we have a location, and for those who know how to convert that into a meaningful address, this is actually located in this Italian island. And here there's the URL that we create based on that location. We use the API key as well, and then we perform our query and we get the content. So the content is provided raw. Yeah, sorry.
Can I just interrupt you, because we have a question from Jay. Hi Jay, by the way.
Yeah.
Thanks for joining. Jay is asking here, can we use Octave HTTP post instead of Gate? I guess it is a yes. Can you answer this question?
Yes. Yeah. I mean, you just have to type Octave HTTP, and here you can see all the methods available. There are 4 methods: post, put, and get, and delete.
Yep. Thanks. And the other question from Jay is, can we use functions like resource.read? So can we read the resources directly here?
Not with that kind of call. For that, you need to use the octave.device API. And here you can get a device by specifying its ID. And then let me show you here, device, like that. And then here in the summary, you have all the resources of that device that were that the device communicated the last time it communicated with the platform. So it's not necessarily the most recent or accurate recording that the device sent, but if anything, it will be stored there. And if you want an actual recording of something, then you have to set up an observation on that device and have it sent to the platform in a stream, and then it's similar to any other telemetry where you have edge values, edge recordings that are sent to the cloud and then processed by Cloud Actions or connectors.
Okay, thanks, David.
So here we have our URL, and so we obtain the result of that URL call. So you have to you shouldn't forget that you get the raw data. So you get the headers, of course, but also the payload is a string that you need to parse. So in this case, the content of that result is stored in the content property, and then you have to use JSON parse in order to parse that JSON. It could be also XML, it could be something else. In that case, you need to use the appropriate function to do so. So actually, you know what? Let me run in the simulator. Since we don't have to provide an event as an input, it's very easy. You just have to do one click. So since I ran it last time, it will stop here. So I will remove the return here so that we can see the function execute fully. So we'll bypass that predicate here. So here we can easily see the result of that. Well, actually here you can see the open weather key, but here you can see. Yep.
And by the way, for you guys watching this video, if you haven't used the simulator yet, I recommend you to use it, to give it a try. It's really nice. I think a lot of features and a lot of enhancements recently in this simulator and in the editor in particular. So that's and tell us, by the way, if you want more, if you have some features you'd like us to go deep down into it, sorry, or if you want us to cover more the editor or the simulator or whatever feature in Octave or in Octave you'd like, it's going to be a pleasure to do more on that. Okay, so sorry for the interruption, David.
No problem. So here we can see the result, and the simulator knows that even though we're dealing with raw data, it knows from the headers here that we are dealing with JSON. So that's why here the preview formats it nicely with pretty printing and syntax highlighting. So we get a peek on the data that got returned, and we see that here we have a hourly property, and that's actually great because it for every next hour, it will tell you what the weather conditions at that location will be. And we have this, so it's a list of objects, as we can see, containing a lot of information. And the one information that we're interested in here are the percentage of clouds. And here we can see that it's totally cloudy because it's 100%. So there's not a lot of sunlight. So let me close that. So once we do that, so we parse it, and then what we want is to extract all the clouds, the cloud level, the percentage level from this array of hourly forecast. So for that, we use the Lodash function map, and we say, okay, we want to put into a new list all the cloud percentage values, and these will be stored in this hourly clouds variable. And we have console log, and it's this one. And here we can see the percentage of clouds. So in the next hour, it's very cloudy, and then a little bit less, and then again very cloudy, and then it's going down, 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 down. At some point, there are very few clouds in like 15 hours or so, and then it's going to be cloudy again. So from all these values, what we're interested in is getting the average percentage of cloudiness, I'd say. And for that, well, we compute the sum and we divide it by the number of cloud forecast hourly forecast readings, and then we get an average cloud. And if the average level of clouds is below a given threshold, so here it's completely arbitrary, but let's say that based on the solar panel, and knowing that if it's not, I mean, with that level of clouds, it's capable of recharging the batteries in 2 days, then okay, that might be fine, but in this case, it's completely arbitrary, of course. Then in that case, we we store a new event in another stream. We call it commands, but I mean, of course, you can call it what you want. And that in turn will be processed by Cloud Action that will send a command to all the devices involved in this monitoring of the volcano, and tell them, hey, you need to, you can now send us all the recordings that you got for in the last week or so. And that's how you leverage, how you pull data, and then how you can leverage that by then communicating and triggering behavior on your devices. So then there's the third thing that you can do with tasks is to aggregate event data to help you monitor and analyze your data. So one common way is to, I mean, since it's, again, it's asynchronous behavior, we never know when devices are going to communicate something. And so we get all this data in streams, but then there can be some noise in it, and so you might be interested in using a sliding window in order to smoothen your recordings. So that's what we're doing here. And with a task, it's very convenient because you can get it to run at a regular pace, and then ask it to fetch the data over a fixed time window, and then apply some aggregation functions on it in order to compute new data, and then push it onto a new stream. So that's what you can do. And these are the aggregation functions available in the querying event querying functions that we'll see shortly after. So there's the sum, the average, the maximum value, minimum value, the unique values, all the values, and that's not actually an aggregation function, but and also the count number of values that are there. And the other cool thing is if you have several sensors that are outputting a lot of data. So for instance, you're monitoring the temperature in the building, and you're going to use different thermometers placed around in your building, and so you get different readings that not exactly the same time. And so here tasks are great to capture a snapshot at a regular pace. So with an asynchronous behavior, there's some chaos to it, and then with a time-based task, you bring some order to it. So let me show you the aggregation functions. I have to watch the time because I talk. Yeah, let's leave. Yeah. So that's what's cool with these sessions, is that we really have time to explore things in depth. All right, so yeah, this function is rather simple. I will show you the stream first. Mango S1. So I go on this device, and then I go to its streams, and let's look at the lights. So that's this view, but this view isn't it better? And yeah, so here we can see the light readings. So if we go back to our connector, no, sorry, tasks, aggregation, and we run it in our simulator, there we get the results of that call. So we call octave.event.aggregate, specify the stream, and then a set of parameters. So here, what's usually good is to, when you want to aggregate over something, is to consider existing values. So here we want to filter out any event in that stream that could not have a light reading. And then we want to group them by day. So that is important in order to get aggregation. And then here we specify what kind of data we want to see in the output. And then the results are the keys that match what we want to see outputted, and with the value. So here it's the average value of the light sensor, the number of values that were matched, the maximum value, the minimum value, and in this case, since we're grouping by day, the calendar day. And so that's for the first day, and then comes the second, the third, etc., etc. We group them by day, just like that. And then with that data, you can, so we could also add here an extra condition and restrict that data to the last day, have it run it every day by specifying one day here, and push the result into a stream, and then you get a nice daily aggregation on this light sensor, for instance. Okay, so to recap, tasks are JavaScript functions like cloud actions. They execute periodically. They don't take any parameter, and they return events that are then injected into streams. And they have this extended device API. Actually, we didn't saw it, but you can also update the device object. You can store things, for instance, in the metadata of the device. And what they enable, well, they enable monitoring the online, offline status of devices, pulling data from external sources, and aggregating data, capturing snapshots, and cleaning up, smoothing your recordings, and to bypass all the noise that asynchronous behavior of devices can do. All right, so that's about tasks. Then there's a second new feature that we deployed actually today. It's about extending the HTTP connectors and the IoT gateway connector. And for us, the connectors are very important because, well, as Charles Darwin said, it's the one that survive are the one that are most capable of adapting to their environment. In our case, it's important that our connectors are flexible enough to adapt to any kind of cloud service. So currently, HTTP-based connectors can compute an event-based URL and payload. You can specify a JavaScript function that takes an event as a parameter and then returns either a URL string or a payload string that will be used then in the HTTP request. And now what we added is a way to also use functions to return a mapping of header names and values from an event. So let me show you that. So let's leave the connector here. So I go here. So this here is an Azure IoT Hub connector. It's taking events from one specific device, but usually what you do is you use a tag. But in this case, we're going to, for the purpose of this demo, stay on that specific device and actually on that specific on the light reading of that device. And then you specify your IoT Hub name, the shared access policy name, and the key. And yeah, so here we customized the data that gets sent to the IoT Hub. In this case, we're only interested in what's in the red sensor object, which contains the light reading, for instance. And then in the headers, what we do is that we use, we check that box here, and this lets us describe a function that takes an event as a parameter, and this function returns an object that maps header names to header values. And in this case, we added a property that is called device name, and it extracts from the path of the event the name of the device, and it stores it there. So then if you look at the event readings on the IoT Hub, so here we're using the IoT Explorer, you can see that there is this property device name with the name of the device. So that's very interesting in this case, but if you scale it up to hundreds of devices, it's indeed useful to be able eventually to have the device name or to have other properties to set up your application. All right, so that's about it about new features. I want to quickly highlight, and since Thibaut mentioned earlier, yeah, sorry.
Yeah, just before you jump into your next topic, I have a question. So if we go back to the tasks on the example you did, so I have a question from John. John is asking, should the cloud values not be matched with the time of the day? So in your example,
this one, yeah.
I think so, yeah. John, you can interact if you want. Give more. I think it's a remark on your use case. Just a remark, a basic remark on your use case.
Yeah, I'm not sure I got the question, but for instance, here we can see, there are not many. I mean, it always depends on how you group your values. So here we group them by day, and on our stream we have several days that are recorded. So that's why we see several aggregations. I don't know if that answers the question.
All right, no, I don't know. John is not answering right now, so maybe you can move on. But I guess you can group by whatever you'd like, right? So it could be by hour
Yeah,
of the
you
day.
can group by something else. Of course, we can group by month, by year, by hour, by minute. Yeah, definitely.
John is saying if it's less cloudy in the night, for example, you need to look only
okay, so it's something else.
at daytime, right? So that's why. I mean.
Yeah, true. Yeah, it's a very naive assumption, but of course you need to not only consider the percentage of clouds, but also the sunrise and sunset, etc.
Yeah, exactly.
And maybe there's a better metric actually to extract this information to at the end to have like an average amount of light that is available in order to charge. I agree.
Okay, thanks, John, for your remark. All right.
Okay, so Timbo invited me to also talk about the way we design our features. So it's of course a team effort to produce all these features, and what we do is user-centered design. So I know that, I mean, a lot of people are saying, yeah, we do user-centered design or user-centric design, but in our case, we have this systematic approach where we identify through interviews, observations, task analysis, what is required, and these are then captured into requirements, personas, and then scenarios that involve these personas. And then during the design phase, we have a very wide brainstorming session where we discuss conceptual model, because of course it's important that it matches the user model, and to see how we can abstract technical model so that users are not lost, but then also not abstract it too much. We also do some participatory design, and yeah, this involves a lot of sketching as well in order to explore the different ideas, the metaphors, the interaction styles that we can use. And then we move over to high fidelity prototypes. So this might sound very daunting, but we have a very, very efficient tool to do this. And this enables us to do videos and prototypes that look as if the app was there and is usable. And this is great to get also early customer feedback by previewing these videos. So maybe some of you might have seen some of these videos. And then, of course, we have the evaluation of the output of this design, and through usability tests, heuristic evaluations, usage statistics. So we sometimes we see that some of the features that we provided are not used very much, and then we realize that maybe we could remove it because it comes in the way, or might harm the interaction with the product, and also through observatory studies. So that's our team. We are 4. It's a very young team, and we have been following this process over a year now of spending a lot of time and effort in this design phase, and then the implementation phase is actually getting shorter and shorter because, well, most of the time and effort is dedicated to design the right product for our customers. And that's it, basically.
No, thanks, David. If you can come back to your last slide, I have a question for you with regard to
which one?
Where this team is located.
Well, it's located in Toulouse. I'm in the Paris area, and so that's for the UI team. Most of the R&D team is in Toulouse, and then we also have our backend members located in New York, and then, as you know, in Canada.
Yep. Thanks. Thank you very much for that. Quick question for you. So I guess we're going to open, yes, the question and answers now. So I already have few questions. Just a quick reminder, feel free to contact the team, Octave team, answers on the forum, Octave forum. You have the URL here on this slide. You will see David, like other people from this team. So feel free to give your feedback, even if you don't have any question. But if you want to give some feedback on, for instance, the UI, what you like or dislike, or what you would like to see, feel free to ask on the forum. You'll have answers for sure. All right. We have 5 minutes left. Maybe a quick question. So I had a question about how do you upload large amounts of data? Can you quickly answer that one, David?
So currently, as of today, it's not really possible. But this is a feature we've actively been working on. So that's why I can talk about it. Otherwise, I wouldn't. This concerns files, the ability to send files. So we want to provide this file metaphor in addition to sending JSON data, and yeah, it's scheduled for this year.
Great.
So you should be able at some point this year to send files to your assets through the Stellar network.
So I guess we'll talk about that in some other session.
In a future session, yeah.
The future session of what's new in Octave. So that's great. A quick question on the max TTL, time to live, of a command when you send a command. Can you quickly answer that one?
Yeah, so we didn't show commands here, but by default there's no time to live on a command. So that's why you can specify this maximum time to live when you create a command. So I invite you to check out the documentation. It's very well described there.
Yep, and I like
the property alongside. Sorry. Yeah.
No, I was about to say that I like that the documentation is very well integrated within the UI itself. It's very helpful. I use it a lot, so that's great. Thanks, David. We are almost there. Maybe if we can go to the last slide, just to quick reminder for you guys. So quick actions for you guys. As I said in the introduction, if you are interested in presenting with us during these sessions, and especially as we have the feedback that people are interested in seeing real real use cases, real applications, and so on. So feel free to join me. You have my email contact here on this slide. Don't forget to register for the next live session that will be on March 11. You can register already on the page. You can follow us on Twitter, Sierra Developer. We post some developer news about Octave, not only Octave, but all CRLS products where we have developers in the community. And you can subscribe to our CRLS YouTube channel. That's where we're going to post this video, this session as a video as well in the coming days. So and there is other type of videos. There is tutorials as well on Octave, and from time to time we add more tutorial videos, more content on Octave and other things. So thank you very much for joining today. Thank you, David. See you soon on March 11th in 1 month. Thank you, guys.
Cool. Thank you.
Bye-bye.